Hello Year 10. Today we are going to be introducing the logarithm laws. But before we do that, let's review our logs that we were doing from last lesson. If we want to evaluate the log base 3 to the power, log base 3 of 27, to work out what that is equal, you can do this. Some logarithms you can calculate in your head if you can ask yourself the question, 3 to the power of what gives 27? Now we know that 3 to the power of 3 equals 27, which means that the answer to this logarithm is the number 3. Likewise with part B, log base 2 of 128, you need to ask yourself 2 to the power of what gives 128. So you might want to use your calculator. You might type in here 2 to the power of 4. Oh, that doesn't give me anything near big enough, so let's try something a little bit bigger. 2 to the power of 8. Oh, too big now, so let's make it a bit smaller. 2 to the power of 7 equals 128, so that logarithm is equal to 7, because 2 to the power of 7 gives 128. Some logarithms, though, you can't do that because they may not give a nice whole answer or they may not look quite right. So in question 2, we have one here where we have log base 7 of 343 is equal to x, and we can solve this by sliding the base. To do that, the 343 stays on the left-hand side, and we slide the base 7 across to the other side, and then it becomes to the power of x. Now we solve this as an exponential equation. So 343, we want to write that with a base of 7. 7 to the power of 3 is 343. Now that they both have a base of 7, that means the powers must be equal, so x is equal to 3. Okay, so the new laws that we're going to talk about today, there are 3 log laws that we are going to learn. Law number 1 says that if we have logarithms that are added together, so log base a of x and log base a of y, they have to have the same base, but if logs are added together, then we can turn that into one logarithm with the same base, and you multiply the x and the y together. Now the law can be used in either direction. You could have 2 things multiplied and separate that to be 2 things added. Law number 2, if you have one log with some things being divided, you can separate that into being log base a of the top minus log base a of the bottom. And again, you can do that in the opposite direction as well. And finally, the third law, if you have a power at the end of your logarithm there, the power can be brought down the front to become n log base a of x. So let's practice using those laws. Question number 1 says, simplify the following expressions in the form log base a of n when n is a positive integer. So you can see here that we have 2 logarithms added together. So this is law number 1. If those logarithms are added and they have the same base, I can turn that into one logarithm with the same base, and I multiply the numbers together. 3 times 8 is 24, and that's it. Part B, log base a of 32 plus log base a of 16. Again, 2 logs are added together, so we can put those together to be one log, and we times the numbers together. 32 times 16 is 512. On the next page, log 2 log base a of 4. Okay, now the goal is that we want to have this just written as one logarithm. We don't want extra numbers floating around. So this 2 that is at the front, we can change that to be a power using the third log law. So it comes up to make that a 4 to the power of 2. 4 to the power of 2 is 16. So it's log base a of 16. Question 2. Simplify and evaluate the following expressions. Log base 4 of 1. So some logarithms we can work out in our heads, others will need a little bit more working out. So in A, we're asking ourselves 4 to the power of what gives 1? So we could write that as 4 to the power of something equals 1. What would that be? And the answer is it's 4 to the power of 0 that gives 1. So the answer to this logarithm is 0. And that works for any time when you have any base down here and it has a 1 at the end of the logarithm. Whereas in part B, we want 7 to the power of what? 7 to the power of what up here is going to be equal to 7. It would just be a power of 1, wouldn't it? 7 to the power of 1 is 7. So this one is going to be equal to 1. Okay, so there are some main rules that are nice to remember. Question C, log base 3 of 1 over 9. Okay, now 1 over 9 is the same as 1 over 3 squared. We could change that fraction a little bit to be 3 to the power of negative 2. And using our third log law, we can bring the power of minus 2 down the front to be log base 3 of 3. The log base 3 of 3, that reminds us of what we did in part 1. We said log base 7 of 7 is 1, so log base 3 of 3 is also going to be 1. So it's minus 2 times 1, which is just minus 2. Part D, log base 3 of 15 minus log base 3 of 5. When we are subtracting logs with the same bases, we can keep the base and divide the numbers. 15 divided by 5 is 3, and log base 3 of 3, or 3 to the power of what gives 3, is equal to 1. Question 3. Prove that log base a of 1 over x is equal to negative log base a of x. Now, if you want to prove something, you want to start with one side of the equation and show that you can get through to the other side. So I'm going to start with the left-hand side. So LHS stands for left-hand side, which is equal to log base a of 1 over x. And hopefully I'm going to simplify it down to get negative log base a of x. So what I'm going to do is, if I have log of a fraction, I'm going to be splitting that to be log base a of 1 minus log base a of the x. Okay, I'm using that to turn that into two logs that are subtracted. Log base a of 1 is one of our special logarithms because a to the power of 0 is 1, so that logarithm is just equal to 0. So it's 0 minus log base a of x, and that's just minus log base a of x, which was what I was trying to get. So I write here equal to the right-hand side. So I've shown that I've started with one side of the equation, I've simplified it down and ended up with the right-hand side of the equation, and that is the best way to set out a proof. Can you please do exercise 3J?